It is November 27th, and we are going to try and go through the setup here. The GoPro and the tablet are going to try and document this for me. I hope that this works okay. And I'm not going to be pointing directly at each of the pieces of equipment because it is probably not going to be real visible. I'll keep the laser moving, the green laser, which is causing me issues right now. Okay, so there's the laser. So there is the positive on the battery pack. Positive on the battery pack goes around through a clamp meter and a voltmeter, comes out on this black connector, or this black cable here. This 2-aught cable then goes into the contactor. There's a pre-charge across it. So anytime that contactor is on, it charges up this capacitor and that capacitor. Other side of the contactor splits and goes to the AC controller on this side, the DC controller on this side through this. That's not actually a connection to the motor. That's just sitting on top of a roll of electrical tape. So there's your positive circuit. Negative circuit starts on the battery post, comes up through this black cable here to this terminal, and it goes through the shunt and into the AC controller. It comes out of the AC waveforms come out of the AC controller on these 3 wires and go into the motor there with the black and the 2 reds. This terminal is also positive going to the DC controller, so it goes through this 300 amp fuse just in case. Goes to the motor negative, so we're switching positive on this DC controller, so we've got the negative connected to the battery pack through a fuse. And then this cable comes around here and goes up into the DC controller, positive. Coming out of the DC controller, we have 3 wires, just like we have with the AC controller, but they're all positive, and they all go to the DC motor. So these 3 get connected together here, and then that comes into this shunt. This shunt is actually decent for showing voltage or showing the current. Set up for 1 millivolt, approximately equals 1 amp. And it's being monitored by this meter. This is the voltage across the motor, and this is the current into the motor. This contactor is just there as an emergency brake and an emergency open, and then it comes to the positive on the motor. This emergency stop switch shuts off power to that one and to this one, and also to this contactor. So that's the positive into the AC controller, the DC controller. I talked about the pre-charge. Yeah, I think that's about it. We will then talk on the DC controller. We have a throttle connected on this gray wire, which swirls around, comes out there. The 20-turn pot, 5K. And then we have a serial connection on this yellow Cat6 cable, which wiggles around, goes through a connector into the laptop for logging. And the contactors are, contactor controls on the DC output are ignored. There's a DC to DC converter that takes 12 volts from this little battery and boosts it up to 24 for use on the board. I've got a desaturation detection just connected with an alligator clip for now because I need to solder it on later. On the AC controller, we have a signal coming from a 64 pulse per revolution signal coming out of the motor, which goes on the blue Cat6 cable and comes into the board here. We also have a throttle, which goes through a little board, adds a resistor on either side of it, and makes the potentiometer, the 20-turn pot, look more like a Hall effect sensor in terms of 0.5 to 4.5 volts as the signal. And then there's the serial connection is right there, which goes through a serial cable and goes into the second serial port on the laptop. Laptop is an old Dell piece of crap that I blew the screen on a while ago. The second screen sort of worked. Logging 2 serial ports and giving me some data logging. This is a little breaker that I'm using as a switch. to turn on the 12 volts to this controller and this controller, as well as the contactor. This little mini breaker shuts off the contactor in the case of a failure where the DC controller does not stop turning the DC motor when I hit that switch. I can also hit that. If that doesn't help, I have the last resort is this mushroom button, which then shuts off the first contactor that we discussed, where the battery voltage is coming into the DC and AC controllers. And after 3 contactors, if I fail 3 contactors, then I guess my motor gets spun up and destroyed, and I go hide in the corner. That's about it. The pack is a Renault Better Place pack. It is 16 cells at 8 volts for 128. And I think it's down to about 125.9 right now. It was supplying, I believe, about 200 amps into this system, but we'll get that checked out with the log files. So if I get into a situation where 3 of my contactors all fail closed and my DC controller is still putting power to the DC motor, I've done all that I can do, and I don't have any redundancies left. So I would then exit the garage door over there and wait for the motor to blow up, because I can no longer shut it off. That's about it for what I did and how I did it. I will be posting the log files for Paul and everyone else to look through to see if I possibly made a mistake or a series of mistakes.